Great to see you here again. My name is Luc de Koster and this is a new video in my series of the Math Survival Guide. When you're here for the first time or you didn't subscribe yet, this is the moment to subscribe to our channel. Click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about this. In this video, I will talk about the problem that I discussed in a previous video, where we try to calculate the average speed or the speed downhill to have a specific average speed. Now I looked into this problem in a different way, and we go back to the problem first. So the problem that fooled Einstein was basically, in my version, me going uphill with my bicycle. Uphill is 2 kilometers, downhill is 2 kilometers, my speed up is 20 kilometers per hour, and I want to have an average speed of 40 kilometers per hour. So how fast do I have to go down? Now we already know from the previous example, from the previous case, that we in fact cannot reach a solution here because we already lost the time going up. So basically, when we look at this example, I would like to understand what is the relationship between the average speed that I want to reach and the downhill speed. I did some calculations like that. So we start from the total time and we look at those different averages that we can reach. Now first, let's have a look at the formulas. We know that the speed down is distance divided by the time to go down, and the speed up is the same, but now the same distance. In this case, we have twice the same distance, d, divided by the time we go up. And we can find from this that the total time that we need is 2 times d divided by the average speed I want to reach, and it's equal to the time to go up plus the time to go down. Now we know that the time to go up is d divided by the speed up, and the time to go down is the same formula, but now we divide d by the speed going down. So basically what we find here, we say in the first case, for example, that the average speed I want to reach is 20 kilometers per hour, and the distance is 2 kilometers like in the original problem. From this, we know that the total time is 4 kilometers divided by the average speed, which is 20. And we find 0.2 hours or 12 minutes. You already see when you look back at the previous example, the previous problem, we would have here only 6 minutes. Now, by the fact that we go or we want to have an average speed which is equal to 20 kilometers per hour, we see that we have 12 minutes, so we have 6 minutes more. And we can say that the t up plus the time down is now t up is 6 minutes, and the time down, when we can write that 12 is 6 plus the time down, which is equal to 12, of course. Now, when we look at those two elements together, we see that we still have 6 minutes left to go down. And when we look at the formula again, this is the same formula, t total is equal to 12 minutes, and it is equal to 12 equal to t up plus t down. T up is 6, and t down is basically also 6 minutes. We still have 6 minutes to go down, and we calculate now that the downhill speed is 2 divided by 0.1, which is 6 minutes, is equal to 20 kilometers per hour. And in this case, we see that the average is, of course, 20 kilometers per hour. We go uphill at 20 kilometers per hour, and we go downhill also at 20 kilometers per hour. Let's look at the different value. Let's look at 25 kilometers per hour now. So we want to have an average speed of 25 kilometers per hour. So basically I can say that we have now that the total time is 4 divided by 25, and we find 0.16 hours or 9.6 minutes. we can say that T up plus T down is equal to 9.6 minutes, and T up is 6 minutes. T down we can calculate now because we have 9.6 minus 6 is 3.6 minutes, so we still have 3.6 minutes to go downhill. And from this, I can say that V down is 2 divided by the 3.6 minutes, or 3.6 divided by 60, and we find about 33.3 kilometers per hour. So when we want to have an average speed of 25 kilometers per hour, we have to go downhill at 33.3 and something kilometers per hour. Now let's do this for different average speeds between 20 and 40 kilometers per hour. And thanks to Excel, I could make the following table here. So we can find the V average and the V down. We have always said we want to have 40 kilometers per hour as an average, or the average maximum that we wanted to have was 40 kilometers per hour. For 20, we find 20 minutes to go down. 21, at 25, we found a velocity or a speed going down of 33.33. When we look at 30 kilometers per hour as an average, we have to go down as 60 kilometers per hour. And when we make the average here, we find basically the values that we calculated. When we look at 30 as an average speed, we find that V up and V down is 20 kilometers per hour, V down is 60 kilometers per hour. And basically what we see when we use the calculations as before, we find 60 plus the 20 divided by 2 gives us 40 kilometers per hour. But we see that we basically did the calculation where we had an average speed of 30 kilometers per hour. So it shows basically that the formula we used before, calculating the average by averaging the speeds, is not correct. And when we go further down, we see the higher the average speed I want to reach, I see that the downward speed is increasing, and it's increasing exponentially. So basically when we go to 40, we see that the downward speed should be equal to plus infinity. And when we calculate the average, then it would be plus infinity, it would not be 40. So basically there is a problem here using the classical averaging formula. When we look in the next thing, I have the graph for different values. The gray graph shows us the time that we have to go down. And we see when we have 20, we have 6 minutes to go down. The scale is on the right-hand side. And when we look at the orange curve, we see the speed increasing, V down. And we see when we reach 40, it's going to infinity. So the closer we come to 40, the higher this speed becomes. And basically it is an asymptote to plus infinity. We cannot find, or we cannot have a speed or find a speed downhill that would give us 40 kilometers per hour. So here you see the graphical representation. It's not really a linear problem that we have. So we have to be careful to find out what is going on. Now, when we look at a realistic estimate that we can have, we could go, let's say, to 31 kilometers per hour, depending who you are, how well trained you are, and how many risks you want to take downhill. And when you look at competitions like the Tour de France and things like that, you will see that going downhill at high speeds can be very dangerous. So basically, Albert Einstein's problem showed us a different possibility, showed us how to calculate this properly. And you see with Excel and a graph, it shows very nicely how this basically works. So this was it for this video. We had a different approach to the uphill and downhill problem. Anyway, I hope you see the possibilities, how you can calculate, how you have to calculate, and I hope you enjoyed this video. Of course, we're at the end of the video. Don't forget to click the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. I thank you very much, and I'm looking forward to seeing you in our next video. Bye bye.